All right, so today we're in section 9.3, perimeter and area of composite figures. A composite figure is made up of triangles, squares, rectangles, semicircles, and other two-dimensional figures, okay? So there are some formulas that are going to be thrown into the mix here that haven't been talked about, but they should be in some of your prior knowledge memory bank, okay? Like the area of a triangle. All right, let's say the formula together. A equals 1/2 base times height. All right, area of a triangle. Area of a rectangle. Area equals length times width. Perimeter of a triangle. P equals A plus B plus C. What does that mean? That just means that I'm adding all of the sides together. All right, perimeter of a rectangle. P equals 2 times the length plus 2 times the width. All right, so those formulas are going to be really important for today's lesson. So in example 1, I'm estimating the perimeter and the area, and I do that by using units. So each block is going to be a unit. All right, so the first thing I'm going to do is I'm going to count the whole blocks. All right, so I'm just going to kind of trace on here to show you what I'm counting first. All right, now with perimeter, remember that's the distance around, So I have 2 blocks over here. I have 1, 2, 3, 4, 5 blocks here. I have 1 block here. Now let's do the top side. 1, 2, 3, 4, 5, 6. So I'll just write 6 here. All right, now this next part is interesting because this the curved part of the arrow covers a half of a block at a time. So 1, 2, this would be 1, okay? Because that's only half of a block that it's cutting through. And then this is going to be 1 as well. And then I'm simply going to add the numbers together. What's 2 plus 6? 8. What's 8 plus 1? 9. And then plus 1 is 10. Plus 1 is 11. Plus 5 is 16. So the perimeter, okay, because they're asking us to estimate, I'm going to say it's approximately 16 units. All I did was I simply added how many units the arrow was covering. Now let's talk area. Okay, so when I'm looking at area, I'm looking at how many units are filling the object. Okay, so I'm simply going to count them. All right, I have 2, 4, 6, 8, 10, 12 whole blocks in there. But then I have these halves again. So I have 12 holes, so area is approximately, okay, so 12 is the number of whole blocks, but now I have to count the halves. 1, 2, 3, 4 halves, which would be another 2 units. So the area is approximately 14 units squared. All right, does everybody see how I did that? All right, just estimating when the figure is on the graph. Any questions with that? I think you might have like one of those on your homework tonight. All right, not saying that an example is more important than another example, but this one is the one that we want to focus on, okay? So when it's not on a graph, I'm actually going to calculate this, and I'm going to get as close as I can, round to the nearest tenth when I need to. But there is a way that I can calculate both the perimeter and the area of this figure. All right, so let's start with the perimeter. The distance around the figure. All right, well, first I need to decide what figures make up this composite figure. So what figure do you see here? Just tell me. A triangle. What other figure do you see here? A semicircle. Okay, so if I want to know the perimeter, all right, well, the triangle part's easy. 6 plus 8, right? But now I have to calculate what the semicircle circumference is. And I have to add that to it. All right, so that's something that we learned yesterday. So this can be practice of what we learned yesterday. All right, so the circumference of the semicircle. Which circumference formula do you think you should use here? Should you use the formula that includes diameter or radius? Which dimension is 10? Is 10 the diameter or the radius? It's the diameter, okay? Because the dotted line goes all the way across the semicircle. Now, if you wanted to use radius, could you just cut it in half? Yeah, you could, all right? But there's not a whole lot of point in doing that. So C equals pi d. C equals 3.14 times 10, okay, to calculate the circumference. Now, we know that when we multiply a number times 10, we don't need a calculator. Look up here. Don't need a calculator. Okay? What happens when I multiply a number by 10? What happens? What happens to my decimal?
Oh, moves to the right.
It moves to the right one place. Because when I multiply it by 10, each place value is a power of 10. Okay? So my circumference is 31.4. But now I need one more step. Because this is a semicircle, what must I do? What do I have to do, guys? I have to divide by 2. All right? Because that was the circumference as if it was a whole circle. So what is 31.4 divided by 2? What is that going to be? Now you can use your calculators. All right, 31.4 divided by 2. All right, should be 15.7. Okay, so now I know that the circumference of the semicircle is 15.7. What else must I add to 15.7 to find the perimeter of this figure? What else do I need to add, guys? 8 and 6. So that gives me all of the dimensions that I need to find the perimeter of my composite figure. So 15.7 plus 8 plus 6 is, all right, so perimeter equals 29.7 feet. All right, any questions there? So the triangle part was easy. I just added 8 plus 6. But the semicircle, I had to calculate that circumference and then add that to it. All right, any questions? Okay, so we'll get through the examples and then we'll get into big ideas and we'll do some practice on this. All right, so area. Now, area is going to take a little bit more calculating. So I need to find the area of my triangle. Let's say that formula together. A equals 1/2 base times height. All right, so let's use those dimensions. A equals 1/2. What's the base of the triangle? Times 6. And what's the height of the triangle? Times 8. Okay? Now, you can do this calculation however you want. You can do 6 times 8 and then take half of it. You can take half of 6 and then multiply that by 8. You could take half of 8 and then multiply it by 6. I would say take half of 6. What's half of 6? 3. What's 3 times 8? 24. So the area of the triangle is 24 feet squared. All right? But that's only part of the composite figure. Now you must find the area of the semicircle. So area equals what is my formula to find the area of the semicircle? A equals, come on guys, somebody knows, pi r squared, but because it's a semicircle, I will divide by 2. Okay, so I only divide by 2 because it's a semicircle. All right, so A equals 3.14. I want you to put in the number that you think goes in for R. Go ahead and plug in the number that you think goes for R. Nate, what number did you plug in? 5. Wait, there is no 5 on there. How did he know 5? How did he know 5? Because it's half of 10. 10 was the diameter. I have to plug in the radius value, so don't forget to do that. All right, then at the end, we'll divide by 2. All right, so now 5 squared is what? What's 5 squared? Is it 10? Is 5 squared 10? No, that's 25. So 25 times 3.14 gives me 78.5. So area equals 78.5, but then I have to divide by 2 because it's a semicircle. So area equals 39.25 feet squared. All right, one more step. What do you guys think is going to be your last step to find the area of the composite figure? What do you guys think? Add the 2 areas together. Okay, so area equals 24 plus 39.25. Okay, so my area equals 63.25 feet squared. All right, any questions, guys? So it's a lot of work because it's multiple figures, but it's doable. There's just a lot of steps there that we have to make sure we keep straight. All right, any questions before we move on to the next figure? Anything? All right, what do you notice about this next figure? What do you guys notice? How many semicircles do you see? 4. What is true about all 4 of those semicircles? They're all the same. So do you think you're going to have to calculate it 4 different times? No, you're just going to calculate it once and then times it by 4. All right, then you have the space in the middle. All right, so first we need to calculate the perimeter. All right, so I'm going to kind of let you guys loose and see how much you can do on your own, and then we'll come back and do it together. All right, so for perimeter, all right, and I know we already talked about this, but I just want it to be included on the video. Is the square involved at all in the perimeter? On the outside of the composite figure? No. Only the semicircles are on the outside of this figure. So we're not going to worry about the square. All right, so in order to calculate circumference of a semicircle, I need a formula. C equals, what formula did you guys use? C equals what? Pi d. Okay, so C equals 3.14 times my diameter of 2. So C equals 6.28. Now, at this point, because it's a semicircle, I could divide it by 2 to find the circumference of one semicircle and then multiply it by 4. Or I could realize that one semicircle plus another semicircle is one circle, right? So this is one circle, and this is my second circle. So either way, so if you take the 6.28 and you simply multiply that by 2, you're still going to get the same answer, 12.54, okay? If you divided it by 2 to find a semicircle and then times it by 4, you get the same answer. All right, so 12.54 is their circumference So that is the perimeter. So the only thing that needs to change is I'm saying the perimeter of the composite figure is 12.54 inches. What now? Oh, 5'6". My bad. Okay, 5'6". I don't know why I said 4. All right, 5'6", and inches. All right, so there's perimeter. Now I have to calculate the area. Now the area is going to include the square because I need to know how much space fills this square. So what is the formula to find the area of a square? A equals, anybody remember? I saw it on your papers. No, for the square, S squared. S squared. So you take one of the sides and you square it. You could also do length times width, but it's going to be the same number because all of the sides of a square are the same. All right, so A equals 2 squared. So the area of the square is 4 inches squared. Now I need to calculate my semicircles. So let's say that formula together. A equals pi r squared. So pi is 3.14. What is the radius of one of my semicircles? 1, because I have to half the diameter. Well, that makes it easy. What's 1 squared? 1. So what's 3.14 times 1? 3.14. So at this point, you can divide it by 2 to find a semicircle and then times it by 4, or we can do the same thing we did for perimeter. How many whole circles are there? 2. So do 3.14 times 2 and you'll get the same answer, 6.28. All right, but now I have one more step to find the area of the composite figure. What do I need to do? Add the two numbers together. Okay, so the area of my composite figure equals 10.28 inches squared. All right, any questions on that one? Any questions? Does everybody see why I multiplied 3.14 times 2 for the semicircles? All right, that would have been the same thing as dividing it by 2 for the semicircle and then timesing it by 4. Would have been the same thing. All right, so let's look at the basketball court. The center of a circle, all right, that's where they do the jump ball in basketball, all right, of the basketball court. It has a radius of 3 feet and is painted blue. The rest of the court is stained brown. 1 gallon of wood stain covers 150 square feet. So how many gallons do you need to cover the brown portions of the court? Now, we're going to kind of go against common sense here because look how tiny that little blue circle is. If I'm calculating this, I'm just going to calculate the area of the court, and then whatever the blue area is, I'm just going to say that that's my extra. I'm not going to worry about it. But let's get specific, okay? So the first thing we're going to do is calculate the area of the entire court. All right? What shape is the court? It's a rectangle. What's the formula for the area of a rectangle? A equals length times width. So A equals, what's 50 times 84? What's 50 times 84? $50 times 84 is, that's a lot of square feet. 4,200. Okay? 4,200 square feet. However, you don't need to stain the little blue circle. So let's figure out what the area of the little blue circle is that I don't have to stain. Area equals pi r squared. So the area of the blue circle equals 3.14 times what's my radius? 3. Okay. So do I multiply first or do I do my exponent first? exponent. So what's 3.14 times 9? A equals what? 28.26. So if that's the amount I don't have to stain, what do I need to do to figure out how much I actually need to stain? Subtract them. Okay, I want to subtract the area of the blue circle from 4,200. So 4,200 minus my rinky-dink little 28.26. All right, what's that going to be? Okay, so the area that needs to be covered is 4,171.74. Okay. All right, so 1 gallon covers what? 150 square feet. So I will now divide this by 150 to see how many gallons I need. 4,171.74 divided by 150. So how many gallons do I need? What's my decimal value?
8116.
What is it?
8116.
Wait. Well, the decimal is A116. Like the decimal.
What's 4171.74 divided by 150? All right, so 27.816. All right, so let's think about it. Can I go to Home Depot and tell them that I want 27.816 gallons of wood stain? No. How many gallons do I need?
28.
28. Okay, so I need 28 gallons. You have to make sure that you answer the question. I need 28 gallons. Okay, we did all that work so we could answer the question. So don't put 27.816 as your answer. Your answer is 28 gallons. All right, any questions there? Okay, now again, I would have just taken the 4,200 and just factored in, the blue spot is just extra. Yeah, but, to go along with the composite figures and all of that, we calculated it exactly. All right, so that's everything you need to know for today.